Hey guys, and welcome back to another YouTube video. So today I actually wanted to again showcase you a project that I made, and you can comment down below if you want to see a tutorial on this project. It's a neural networks project. Like it's not exactly basically what I've done over here is I've implemented style transfer into neural networking, and you will see what it is. So basically, what style transfer is if we give one kind of like content image, a image which actually you want to style, an image that you actually want to like you want that image to look a bit better. So that will be called the content image, and then the image that kind of contains all of those styles and stuff. That's called the style image. So first, what I did was I took a content image. The content image that I went with was just a face of me, just my face, as you can see over here. This is my face, and I made it so that I was smiling like this because I actually needed it for another neural network. So for that I had to smile. So I just used that one, and then I went with the style image. This is the style image. It's just some abstract art, and I just got that one. And you can see basically what I'm doing is I'm taking the content image and I'm taking the styled image. I'm kind of like taking the style image and putting it inside the content image in a way that the content image does not get destroyed. Now you will see exactly what I mean a little bit later on once all of the epochs run. But yeah, so that's basically the actual idea. So you will see over here in the image.png how all of that stuff will actually be looking, and just wanted to tell you that. So you might be saying, well, that's a lot of code for doing something this simple, right? Well, yes, but this thing is actually not as simple as you think. This is actually something pretty complex. You can't just do you could use some CV2 and fancy image processing to achieve something like this. Or when you'll actually be doing some complex image mapping, you won't be able to use OpenCV because that's just basic computer vision. You need to use artificial intelligence for that. So the way we do it is we first, now all of this stuff I myself don't understand what this stuff meant, but I'll make you understand like most of it because I actually went through this stuff into the documentation. They used another example. I changed the code a bit and made it so that it would uh, fit all of this stuff to my images. But it's pretty much the same thing. It isn't really that different. Basically, what I did was I first converted a tensor to an image. So what I could do is I could take a tensor. If you don't know, tensor is basically like a vector, but it's got some stuff added onto it. I myself like it's a pretty mathematically dense abstract topic. So we take a tensor and basically we want to convert it to an image. Now what I did here was I just loaded in the images for the content and the style, and then what I did, I applied this load image function, and basically what it would do, as you can see, I get another generated image with that abstract art on my face. Now the thing is, I really didn't go with a lot of epochs, so you won't see some really good things, because the thing is, this thing takes up a ton of your processing power. This thing is really computationally heavy, so that's why. So first of all, what I did was I just made a function that would load an image, and then I just made it so that it would show an image. Now I didn't call the show image because I was not running a Google collaboratory that I could have like individual code outputs. But then what I did was I took this thing called a content image, and then I basically just called the load image function with my content.jpg and my style.jpg file, and this basically shows that image. But didn't I commented out my plt.show because otherwise then there are two ways in which you can define this. You can literally you can do this entire thing in these many lines of code, or you can actually do all of this extra code. Now you might say, why aren't we just doing it like this? Because basically if you just uncomment this and run this, and it will generate the image for you. You won't need to deal with any TensorFlow or AI stuff. You just will need to uncomment this line of code. Then you might say, why don't we just do that? Well, because we are here to learn. We are not here just to get a result. So we could do that, but we won't actually learn anything. We will just learn how to convert an image into a tensor, how to convert a tensor into an image, which is pretty straightforward if you will look at it. So you could do it in this way, but we don't want to do it. So what we will actually do is we will use this thing called the VGG19. I'm sorry. Basically, what it is it kind of is like it's like a rough definition of the VGG19 can be like YOLO. It's not exactly like it. As you can see, we have another image popping up, and you can see with every passing epoch, this image looks more and more, I would say, better. Like more and more, it resembles like it kind of gets styled a bit more and more, if you understand. Like this VGG19 is kind of sort of like YOLO. Basically, what it will do is it will have it's kind of like a pre-built model, and we basically grab that pre-built model and we can just apply layers on it. Let me actually explain it to you better. So if I go through some of the extra code, then I think you will understand this stuff a bit better. Basically, what happens is over here in the VGG19, there are a lot of blocks of convolutional layers. So what we do is for the content we want one block of the convolutional layer, and for the style we want these five blocks of convolutional layers. And basically that's what we are doing, because actually coding out all of these blocks will actually require, like, the code is pretty straightforward, you just need to add a convolutional layer, but the amount of code that you will need to write will be a lot, and like it won't even really make sense to do that. So basically what we do is we load in a model, and then we just grab some specific layers from the model instead of actually having all of those layers. So then what we do is we just do some processing on the VGG layers, and like we load it as a model, as you can see, because currently they are just layers, we need to load them as a model. And then what we do is we just extract the styles, and then what we do is we just print out some stuff about the image, as you can see, the shape, the min, the max, and all of the mean and stuff. So next what we have done is the style content model. Now basically what the style content model is, as you can see, we are just taking the stuff, we are we take the outputs and we basically put all of them as, let me actually show it to you. I really don't think I will be able to explain. As you can see, we put them like this. So as you can see, we are currently just we process the image and we return some stuff about it. Like as you can see, the shape is 512, and then we reduce the shape. That's kind of what we do over here. Then what we do is we extract all of the kind of the what do you say, styles of the image, and like what exactly do you think contains in the image. What are the actual, like if you have a dog in the image, basically what it will do is it's kind of like a dog, and then it will apply some styles around it. As you can see now, again we have some more convoluted styles. So let me actually make this a bit smaller so you guys can see it a bit better. Let me make this a bit kind of smaller. All right. And as you can see now, as you can see, it's getting more and more and more, I would say, dense. But you can see that you can still make out that this is my face. It isn't getting lost and something like, it isn't like you only get the style and you don't get the content. The content doesn't get lost. That's kind of the whole idea of the entire network. So that's what we did over here. So we just return the contents, and then what I have done is, now some stuff over here I really can't go over to explain, because you know if I go over to explain you that stuff, then it will be really it will take me a lot of time. Now the style weight and the content weight basically means uh, kind of like, in the paintbrush applications, we have the weights and of the paint brushes, and the more the weight and all of the thickness, the more darker and stuff. So basically what it means is, how when you have some content and some style, how much styling do you want to actually apply. So when you actually reduce the style weights, it will reduce that. Currently, as you can see, e means exponent, so it's 1 to the power of negative 2, so it's 1 upon 100, and this is 1 to the power of 4. And then what we do is this is just calculating the loss and all of that stuff. And here what we do is we take the gradient. We don't know what the gradient means. It's like that if you have a slope, and at one point what is the slope of that slope. That's the meaning of gradient. That if I have some surface, then what is the slope of that surface, how does it actually go down, does it go up. So that's basically we calculate that. And then I have just given it epoch, steps per epochs, and then I have just, this is just we are displaying the image. As you can see, we are saving the image and then displaying the image, and then we are just showing that the training steps are going on and all of that stuff. And then we just say what was the total time that it took. Now currently, as you can see, we get this thing called image.png. uh, so let's see how many epochs have run. So this is the final epoch, I guess, or the second last epoch, if I'm not wrong. All right, this was the final epoch. As you can see, it prints out the total time. And now I guess we will be able to view an image.png file. And there we go. So as you can see, this is my face with this style and this face. And how, you can see that how you can actually map this stuff, and you can see how good it looks actually. Like, it doesn't look good, but you can see if you actually take the correct combination, if you take a good style and if you take some good content and if you map it together. So maybe if you can have like Picasso's painting and Da Vinci's Mona Lisa, and you can map them together, see what painting comes up. Then what you could have is like, I actually did another project with this, was that I took the Mona Lisa and the Leonardo da Vinci's face. I took Leonardo da Vinci's face and put it into the Mona Lisa. Saw how it looked, and it looked kind of good actually. Didn't beat the actual Mona Lisa painting, but it looked good. Now you might say that instead, can't we just use this shortcut? You can surely do that. Again, I told you, if you have if you are pretty bored, you don't want to go through the pain of, right, like uh, googling up and understanding all of this stuff, you can definitely just use the default code that we have over here, the shortcut. But if you actually are determined to actually understand what is going on behind the hood, then you should surely go about this entire process. And I myself haven't written even 1% of this. I have written some parts of it, I have modified some parts of it, but like most of it is the same. So you won't have to modify most of the stuff. So that is pretty cool. So basically what I want you to do is go up to Google Chrome, and I'm just going to show you the perfect website where you can pretty much copy paste all of this stuff, and you will be able to do all of this. So go up to Google Chrome, just search for TensorFlow, and just go to the uh, auto encoders, and then it's like a part of auto encoders. Like, it's not exactly a part, but it's like a generative image thing, as you can see. Yeah, so the neural style transfer, it's a generative AI. If you don't know what a generative AI is, it generates stuff. Like, it's not just classification, it's generation. So as you can see over here, they have this thing where they have this dog and they have some styles and stuff behind it. But the only kind of like problem that I faced with TensorFlow was documentation. As you can see, I've pretty much copy pasted a lot of it. Is that they use tf.keras.utils.get file. It is pretty cool. Only and only if you are using some web-based file. Like, I could Google up images of Mona Lisa and then I could like use the same thing, but it won't really work if you are wanting to use local files, which I guess a lot of you will want to use, like local files, like what I have done. For that, basically you will just need to change some things. Like, basically you will need to change only a few things, and I'm gonna show you. And if you are going to be writing code in Visual Studio Code and not Jupyter Notebooks, you will also have to change a few things. So I'm gonna be showing you all of that right now. Basically, if you're wanting to use local images, instead of using tf.keras.utils.get file, you will need to use plt.imread, and for that you will need to import from matplotlib.py import plt. You will just need to import that up top, as you can see. Next, what you will need to change is you will just need to modify the load image function that we have, and basically you will just need to write this. I'll have all of this code in a GitHub repository, which I'll have linked down below, so you will be able to view all of the changed code. I'm just gonna be going over what I had changed, so that's why. Next, all of this code is pretty much going to be the same. Another thing, whenever you will be dealing with all of this stuff, you'll actually need to show. Now, the thing is, you will be running this through a terminal window, obviously, and terminals can't show images, and we are currently using the ipython display. If you don't know, as you can see, we are using the ipython display library, and ipython.display can't display stuff to the terminal window. At least in the Mac that I am using, you can't do that. It will just show you that there should be an image over here, but it actually won't show you the image. So for that, what I you basically need to do is over here, where just below here, you need to put in, when they are converting the image tensor to an image with the tensor to image function that we had defined up top. Here you just need to take the entire tensor to image. You need to encapsulate it inside of this variable called display image or whatever you want, and then you will just apply this thing, and then you will just say pld.im so display image, pld.savefig. Now savefig is up to you, and then you will just need to call the pld.show. Now a lot of these areas, like in Jupyter notebooks, it kind of cuts down the code that you need to write, so you will need to do some stuff like this what I just told you. I don't think there is any other thing that you need to change to do this. So yeah, that's pretty much it. Now you need to install a few libraries. You cannot do it without that. You need to install TensorFlow Hub, and you will also need to install. I think you needed to install one more library before you actually went and did this. Let me actually open this up in Google Colab, so you guys will be able to see exactly which libraries you need to install to work with this. I managed to install all of them. It isn't really very difficult. You can just do it with pip. It isn't that complicated to install these. uh, I don't know, like, yeah. So as you can see in neural style transfer, you can just go down. um, okay, where is it? All right. Okay, I don't think they have gone over the installation in this notebook. They usually do, but you will need to install a few libraries. You can just copy paste my code, see which libraries are not pre-installed in your like thing, and then you will just be able to pre-install. So that was pretty much neural style transfer. As you can see, not that complicated, but pretty long to write. You can definitely go through this code, see what you can understand or not. And the best way, the way I actually understood this, I just read through this documentation. As you can see, they have some stuff like define a function that load the image and set its maximum dimensions to 512 pixels. And I think you can understand over here it says max dim 512, and then we are just reading this stuff. Then what you can do is you can go down and you can see this tutorial demonstrates the freestyle algorithm and stuff. As you can see, before getting into the details, there is already a model called the TensorFlow Hub model. If you will actually go over here, you will be able to see that. If you open up TensorFlow Hub, tfhub.dev, you will be able to see that we can just use TensorFlow Hub for this, as you can see. And you also have TF Lite Hub, as you can see over here. So it isn't like you just can. So that's that. So you can see currently that's what is happening in neural style transfer. You can use like these shortcuts, because as you can see the code is not that short. The code is pretty long. So that's why they provide you all of these shortcuts. And one thing that you also need to keep in mind, one second, let me just have a check on the recording. All right, one thing that you also need to keep in mind before you, like, if you are using like some web-based image, is, let me actually show you. So if I just search for Mona Lisa images, what you need to do is I'm just gonna go to the image tab, and I'll just go over here. And basically what you want to do is you want to first click on the image. You want to go to the website which contains that image. In this case it's Wikipedia. You want to right click on that image and you want to click on copy image address. Now it's not done over here. What you want to do is you want to paste the image address wherever you want, and you want to copy this actual name of the image. You will need this name of the image. So basically in the slash you want to check till where is the, what is the name of the image, and you want to keep the name of the image. And then what you want to do is you want to first put the name of the image and then put in the entire URL. So if you don't do that, then again it won't work. I know there are a lot, as you can see now, this thing will appear as you can see over here. So yeah, so that's kind of what I wanted to tell. There are a few things that you need to take care about. You can't just sit down and do all of this stuff by yourself. You need to read the docs. So yeah, as you can see, they have some really good documentation, the networks in this, so you can extract the image, and then they also tell you all the actual code. And then what you can do is you can go a bit up the place where they load in the VGG model. Okay, why is my mouse lagging? Alright, so as you can see now, load a VGG19, and as you can see in the predicted top 5, like what I wanted to tell, it kind of like returns what it thinks there is in the thing. So as you can see over here, just wanted to tell that. And as you can see, there's like everything that you want to understand is already present over here. And also one cool thing that I wanted to show you guys is, let me actually see if it is over here. Okay, I think it's not given in the TensorFlow docs, but if you go over here and run it in Google Colab, there will be a few extra code blocks that will actually give you a visual output of how it actually goes about doing this stuff. Like it will show using some matplotlib things. It will show how all of this neural style transfer actually works. Now I won't really go into that. I'll need to run all of the cells again and stuff. It takes some time, so that's why I won't go into that. But you can yourself play around with it. And